Welcome. I'm building an action RPG with evolving computer-generated creatures. The game is called Where Beasts Were Born, and you can wishlist it through the link below. My evolution system is based on a genetic algorithm. I can mix the DNA of parents to generate new offspring. If I let those creatures which perform well reproduce more often, the population becomes more efficient at the task that I give them. Usually, this task is to defend their homes against evil witches, played by you. My goal is to build something like a roguelite gameplay loop around these mechanics. I want the beasts to learn, adapt, and change with every round you play against them. I've gotten so much great feedback after the last devlog, and it's awesome to see how many people already care about the game. We have a ton of cool ideas floating around the Discord server for possible player abilities, creature evolution, and changing biomes. But because every beast is unique and created automatically, I first had to face a few challenges that other games usually don't have. In this devlog, I want to discuss how procedural creatures have made my life as a game developer very difficult, and how I solved some of these issues. As always, I promise to keep it a healthy mix between technical details and pretty videos of scary beasts. Last time, I showed you 3 possible game modes. After all of your feedback, I decided that I'll focus on the single client solution for now. Here, a generation of beasts is created and let loose in a cave together with a player. At the end of the round, all creatures are rated according to a target function or fitness score. Those with higher scores are chosen as the parents of the next generation, passing on their traits, and the cycle continues. The first prototype worked quite well, and creatures evolved strong armor or very quick movement. But I soon noticed 3 major issues. First, the game itself was getting too slow on my old laptop, especially when I was recording videos while playing against larger groups of beasts. I bought a new PC, which was made possible by my new Patreon supporters, thank you all so much. This made recording a lot smoother, but the game was still not always running smoothly. So I did some profiling and noticed that a large amount of processing time was spent on the animation system. Because each creature is unique and they move and climb through complex terrain, their animation has to be calculated on the fly. The game uses a complex animation system with a mixture of inverse kinematics to control legs, tails and necks, and forward kinematics to control the spine. The game engine, Panda 3D, gives me a choice in which language I want to code. I mostly use Python, which is fast to write but can be slow to execute. That's usually not a problem, because my code mostly just calls very fast intern engine code, so all of the heavy lifting is done in C++. But in the case of my inverse kinematics code, the picture looked more like this. So I did the sensible thing and rewrote the leg animation code entirely in C++. Which brings me back to this situation, and now I can simulate hundreds of legs in real time. Next, I simplified the torso animation. Originally, I controlled each torso segment individually, but that's expensive for longer beasts. So I now merge neighboring spine bones to create larger segments. Afterwards, the creatures were slightly besides themselves for a while. But now the spine animation is a lot more efficient, and I think it looks just as good as before. I also changed how new foot target positions are calculated. They now anticipate the rotation and look more natural. Then I cleaned up the code that calculates leg speed and stride length, which I think helps a lot in distinguishing the animation of thin insect-like creatures and larger, slower beasts. I think I might make a full video on the creature animation at some point, because there are so many interesting aspects to it. But I'll leave this topic for now and move on to a more pressing issue that I found. Creating a new generation of beasts took too long. In the prototype from last time, after every round I had to wait for a few minutes for the new generation to be ready. In extreme cases, the actual playing time was shorter than the waiting time. I noticed that it often actually only took 3 to 5 seconds to create the 3D mesh, but then I need to create details on the surface of these meshes, and these details have to be baked into 2D textures so that I can then use them in the game engine. This baking process often takes another 25 seconds or so, and it's the bottleneck. As you may remember, these details in the textures are important for the gameplay because they show which body parts are armored. I thought of a few ways to speed up texture baking, but they all come with drawbacks. But then I took a step back and recalled just how incredibly fast modern PCs can render tons of triangles. So I wanted to try if I can simply use real geometry for the scales and armor instead of only textures. It turns out this works really well, renders fast, generates much faster than the old system, and as an added bonus, I think it even looks much better. I start with the base mesh and set up a geometry node tree which distributes random points over the surface. Then I create a single scale and let the creature's DNA control the width, the height, and what I like to call the spikiness. I could then instantiate this same scale on every surface point, but this gives me very little control and looks boring. So instead I create various layers of scales in decreasing sizes. When I combine these all, the whole creature is covered in scales and I can control their shape, their density and their sizes. But so far I have very little control over where on the body I want heavy, thick scales and where there should be smaller scales or no scales at all. So before distributing the geometry, I estimate the mesh curvature and store which vertices are part of the legs, the eyes and the spikes, so I can use this info later on to control these aspects. A trick that I kept from the texture-based scale system is these spheres, which control where the armor is present and where it's not. Like everything else, the sphere position and size is controlled by the creature's DNA, so it can evolve its armor over time. In the end, the geometry node tree might have gotten a tiny bit complicated. It also took way too long to figure out how to make the scales animate correctly with the base mesh. My idea was to copy the bone assignment from the base mesh to the scales. But it turns out that reading these assignments in geometry nodes is quite complicated. But I figured it out and now the animation works in-game. In the future I might tweak this some more. For example, I want to rotate the scales for a more natural flow with the body, but for now I'm very happy with the control and diversity this system gives me. A huge advantage is that I can probably use the system to scatter other things across the creature, like fur, or crystals, or sacks full of poison, or spikes, or mushrooms, or feathers. But for now, I consider these first two issues as solved. This brings me to the last issue that I found, which is probably the most important one, and also the most challenging one: the gameplay. The prototype from last time worked pretty well. I thought I just had to add a few more player abilities and a cool magic system to turn it into a first playable demo. So I started with some close-range weapons and spent a lot of time thinking about aiming and magic systems. But I noticed that this won't work. First, the close-range system felt really awkward. Aiming precisely from a bird's eye perspective was really difficult. As a side note, it looked strange to me that a tiny witch would stand so close to a huge creature and not just be killed with a single bite. I think it would fit the vibe of the game much better if it would encourage you to approach a fight with more caution and avoid getting swallowed as much as possible. And the biggest problem was that this won't lead to enough variation in the interaction between the player and the beast. The tactical choices for both the player and the creature would stay way too limited. Imagine this situation. Usually the creature will approach you head on. You might stand your ground or run, but your attacks will likely always be aiming at the head, because you'd never reach those strong hind legs to slow the creature down, or the weak spot in its back. I see a couple of possible gameplay changes that might solve this. First, arcing attacks or very quick player movement could allow the player to attack from the side. A cool idea from a Discord user was that maybe magic attacks could be guided by attracting or repelling forces. But I fear that these solutions would lead to a situation where you just always try to outrun the beast. Another solution might be to give the game a strong focus on setting traps and turrets. Then, while the creature tries to break free or attacks the turret, the player has the time to flank or to ambush. I really liked this idea for a while, but the repeated setting up of traps might slow the pace of the game down too much, and I really want the players to move around and explore the caves. Also, the more I thought about this, the more I realized that this might turn the game into a constant slaughtering of trapped, helpless creatures, and ironically, that just made me really sad. I was stuck on this for a while. Then my brother reminded me of a simple fact that changes everything. The player could control more than one character. With this change, the player can flank, reach weak spots, distract, or get out of reach if necessary. The creature now has to decide whether to attack the character in front of it, or the powerful mage that has been dealing lots of damage but is harder to reach. I see so many advantages that come with this change. First, it opens up a lot of new tactical possibilities for the player, but also the creature. For example, when multiple creatures are involved in a fight, Some could specialize on attacking the tank, while others could specialize on distracting the scout. Also, this whole setup would extend very naturally to a multiplayer mode. I'd really love to hear your thoughts on this. If you know a cool party-based game or have suggestions of how the controls could work, please let me know in the comments below. I thought this video would just be a short update, but it turns out I have so many things to show that they won't all fit. So I'll end this video with a summary of the most important changes. We tested out a music system that stacks vertically. All layers are always on, but the more intense layers are only tuned up when you engage creatures. I think this already makes the game feel a lot more dynamic. I also started working on a menu. A lot of this is placeholder art, but this was one important missing piece on the road towards a demo. The menu also has a piece that I'm really looking forward to developing further, which is the target function designer. The idea is that you can customize the fitness score that the game uses for the next run. I'll probably lock some terms at the beginning, and you can find their recipes and unlock them while playing the game. Finally, after way too many iterations on the logo, I feel like I might slowly be homing in on a final version. Let me know how you like it. That's it for today. If you want to help out, please wishlist on Steam, support on Patreon, or join the Discord community. See you next time.